Hi, I'm Paul. We are doing AP Computer Science A multiple choice practice test. I don't know. I don't know. Well, it says there are 46 questions. I think that's more than usual. I don't know why there are so many questions, but uh, here we go. Let's take a look. Uh, a oh, why am I in question 11 here? Hang on. Uh, and all right. A student's test score can be any real number between 0 and 100. The intent of the following class is to print a student's score as a letter grade. All right, so here's the class. There's a private variable called score. There's a constructor that takes in a score and prints the grade. All right. Consider the following test segment of a client program. Test report T. Blah, blah, blah. New test report, test score T, print grade. All right, so we send in 75. 75. All right, so looking at this, this is a common question where you've got a score and you want to assign a grade or something. There's a lot of ways to do this correctly, with returns or with if else, but this is not one of the ways to do it correctly. So we'll send in a 75. Is the score greater than 90? No. Is it greater than 80? No. Is it greater than 70? Yes. So we'll print average score, but there's nothing to stop it there. So it's going to keep going. Is the score greater than 60? Yes. So it's going to print barely passing. Is it less than 60? No. So it prints those two things, average score and barely passing, which is B. I encourage you to look at this and understand it because it's so common. It's just there's multiple ways to do it right and there's multiple ways to do it wrong. And this is one of the ways to do it wrong. So let's do next. Whoa, what happened? Oh, I see. Oh, I should probably show the answer is what I should do. Okay. Yeah, B. Okay, next. Consider method do something below. All right, so we've got a nested loop. I goes from 1 to 5. J goes from 1 to I. And then J goes from 1 to 5 minus I. So what is going to happen here? So we just take stuff like this a piece at a time. All right, so I is going to go from 1 to 5. J is going to go from 1 to I. All right, so that means first time through this inner loop, J is going to go from 1 to 1, then it's going to go from 1 to 2, and so on. Eventually, it's going to go from 1 to 5. And what is it going to do? It's going to print a dash. So, and then at the end of this inner loop, there's a println, but so the first time through the loop, it's going to print 1 dash, and then it's going to print 2 dashes, and then it's going to print 3 dashes, and then 4 dashes, 5 dashes. So let's do a process of elimination here, just on that. All right, A doesn't do that. B doesn't do that. C does do that. D is close, but it's only 4 lines. And this loop definitely goes 5 times. So really that's as far as we need to go on it, because C is the only thing that does this. So let's take a look at the answer here. Yeah, you selected. This answer is correct. I look at something like this. It's a little bit confusing, but just take it a step at a time. I is going from 1 to 5. J is going from 1 to 5, 1, each time through the loop. So you're going to get 1 dash, 2 dashes, 3 dashes, 4 dashes, 5 dashes, and there they are. 1, 2, 3, 4, 5. Okay. Next. Suppose A and B are Boolean variables. The expression not A and not B will evaluate to false whenever. Okay, again, just break it down piece at a time. That will be false when either not A or not B is false. In order for that to be true, both sides have to be true. Now this, not A, is false when A is true. This is false when B is true. If they're both false, the expression will be true. We just need one of them to be true. So if B is true, yeah, it's false. We don't even care what A is. But if B is true, it's false. If A is true, it's false. We don't even care what B is. So 2 and 3 are false. All right. Consider the following classes. Clown and acrobat are subclasses of circus performer. Which of the following is true about the classes? A, each of the classes can have a method, do, trick that has different code. Yes, that's polymorphism. And you need to be super familiar with that. Polymorphism, yes, that is true. But let's go ahead and look at the other ones anyway. Something like this. You know what? I need a pen here. Okay. This. Oh, it's gonna go white. I need black here. Inherit constructors. When you see something that says inherit constructors, that's false. You never inherit constructors. All right. This. And this comes up a lot, the inherit constructors. It's always false. Here's something that comes up a lot. Circus performer has a private instance variable, and the subclasses are going to access it. False. If a parent class has a private variable, private instance variable routine, I'm not sure what that means exactly, but anyway, the thing is private. If a parent class has a private variable or method, it is not accessible in the subclass. If it has a private method, same thing. Private method, no, you cannot access it. If it has a private, oh, I see, private instance variable. Okay, this is no. Again, it's the same. It's the same thing. It's the same thing over and over. So the correct answer is A. That's polymorphism. And oh no. I gotta click show answer. Show answer. Sorry, show answer. Yes, A. All right, next. Consider the following class, piggy bank. I wouldn't read the whole thing yet. I want to see what the question is. So give me some context. Okay, what is a correct implementation of increment total? All right, now we can look at it. Piggy bank. It has a double variable, total. It has a Boolean variable, is full. It has a getter for total. It has an increment total. Okay. Again, the pen here. This return. So the first thing, if you see return, is look over at the method. All right. This doesn't return anything. Okay. It's void. So that's wrong. Return. That's wrong. Total plus equals amount. Okay, so amount is the input variable. Total, increase total by amount. So total plus equal amount is fine. Total is up here. All right, get total plus equal amount. No. Get total is just it's gonna return a double, but it is not going to increment the total variable. Okay? This is going to change the total variable, but not in the way that we want. Total equals amount. No, we want to increase total by amount. All right, so the only thing that works here is C. Where is show answer? I guess it's down here. Okay. Which is the correct implementation of change piggy state? What is change piggy state supposed to do? What happened here? Oh, okay. Change piggy state. If it's true, change it to false. If it's false, change it to true. All right. This says if it's true, change it to false. The only other option is that it's false. And if it's false, change it to true. All right. It works fine. This is actually a better implementation here. Just reverse it. If it's true, change it to false. If it's false, change it to true. That's fine. What about this one? If it's full, yes. But what's missing there is it doesn't deal with the case that it is false. So that's out. It's 1 and 2 would be the correct answers. And that is D. Okay. Consider the following guessing game. Consider the problem of writing a game in which a user thinks of an integer from 1 to 1,000 inclusive, and the computer tries to guess that number. Each time the computer makes a guess, the user makes one of 3 responses. Lower, that is, the number is lower than the computer's guess. Higher, meaning the number is higher than the computer's guess, or you got it. All right, suppose the game is programmed to use a binary search strategy for making its guesses. What is the maximum number of guesses that the computer could make before guessing the user's number? Okay, good question. This is testing your knowledge of binary search. Binary search throws out half the search space in for each guess. So the maximum number of guesses is the base 2 log of. So let's say the base 2 log of n, whatever n is. In this case, it's 1,000. It's probably good to know that the base 2 log of 1,000, I mean, it's about 10. The base 2 log of 1,000,000, it's just about 20. So the answer is going to be 10. 2 to the 10th is 1,024. That'll work. You might say, that's too high. Why don't we just use 9? Well, because 2 to the 9th is only 512, not big enough. Okay, so the answer to this Problem is 10. Okay. This is the same. Oh. Well, that's a good question. The way this is phrased, all right, so now we're going to do a sequential search strategy. What is the maximum number of guesses the computer could make before guessing the user's number? Now, the key here is this before. Worst case is that you pick 1,000 and the computer starts guessing. 1, 2, 3, 4. It's going to take 1,000 guesses. But what does it mean to say, I don't like this question for this reason. What does it really mean to say, how many guesses is it going to make before guessing your number? Again, it could make 1,000 guesses, but if you want to take a literal interpretation of this, it's going to guess the right number on guess number 1,000. And so the number of guesses before guessing your number is actually 999. I don't like that question because it's sort of open to interpretation, let's say. But let's go with that and see. Yeah, 999. Okay. And let's scoot this over. Okay. Consider this hierarchy of classes. So the hierarchy is we have an entree class, and then we have a number of subclasses of entree. The entree class has a method, print recipe, with the following header. I would note that because there's a semicolon right here, that it doesn't have an implementation. It's going to be an abstract class. How can you print a recipe for an entree? It has to be a particular entree. Now, this method is overridden in each of the subclasses. A client class recipe book has a private instance variable, all recipes declared as follows. Private entree, an array of entrees called all recipes. And it is correctly initialized. The following, whoa, hold on. Okay. It is correctly initialized. The following piece of code is now executed to print a recipe for each subclass dish. What is illustrated by this code? Overloaded methods? No. Make sure that you know the difference between an overloaded method and an overridden method. Does it say overridden? Yes, right here, overridden. Overridden method. These are overridden methods, not overloaded methods. Polymorphism, yes. But let's look at the other ones. Procedural abstraction, no. Information hiding, no. Encapsulation, no. This is a classic example of polymorphism. You see polymorphism a lot in the context of AP Computer Science when you're dealing with class hierarchies where subclasses override a method in the parent class. So you can call, what is the method called? Print recipe. You can call print recipe on an entree object and get a different result every time depending on what kind of object is actually in the entree object. It's going to be a subclass. So is it lemon chicken, braised beef, rotura, etc. It's a classic example of polymorphism, and so I'm going to go with that. Okay. What is a false statement about static methods? Let's see. A static method can use a static variable in its implementation code. Yeah, I don't see why not. If a class is such that it doesn't make sense to ever create an object of the class, then all methods of that class should be static. I mean, that's not false, really. It's kind of like the math class in Java. Everything in there is well, yeah. We will never create like an object or an instance of the math class. You don't see like math m equals new math. So everything in there is static and it's just accessed by class name dot property or method. All methods in a class that has a main method and no private data fields should be static. You think about that. It has a main method. It has no private data fields. Okay, so you're probably not going to create an instance of that class. The reason being the main method is static, and a static class can only access other static main method is a static method. It can only access other static methods or static variables. So those are not going to be accessed. So there's no reason to create an instance of that class. So I'm going to go true on C. A static method should not be invoked by an object of a class. A static method should not be invoked by an object of a class. Let me think about that for a second. I'll say true on that. I mean, you could do it. It would be discouraged because a static method does not belong to static methods. A non-static method. What am I trying to say here? A static method belongs to the class as a whole. It does not belong to each instance of the class. So if you create an instance of the class and call a static method, that'll work, but it's discouraged. So if we want to say should not be invoked, yes, I would agree with that. Accessor methods, now we get to something that makes sense. Accessor methods in an object class may be static. That makes zero sense because you have accessor methods so that they can be invoked by other classes, and if you make them static, then an object will not be able to invoke that method. So this is going to be, let me turn that off. This is going to be E. Accessor methods should not be static. Programmer needs to produce a random int in the range 20 to 30. A statement that does this correctly is 10 times math random plus 20. No, because 10 times math random is going to produce a number from 0 to almost 10. Well, actually, hold on a second. No, well, okay. Let me start over. 10 times math random is going to produce, let me get a pen here. Ten times math random is going to produce a double. All right, not an int. So that's out. 11 times math random, that is going to produce a double, not an int. That's out. Math random, if you just call math random and cast it to an int, you're going to get 0. And so this is going to return 20. It's wrong. This one, math random times 11 and cast it to an int. All right, so math random, as you know, produces numbers from 0 to 1, but not including 1. It's a double. It can get very close to 1, but not 1. So this is going to produce a number between 0 and something very close to 11. If you cast it to an int, you're going to get a number between 0 and 10, and you're going to add 20 to it, and that is going to give you a number between 20 and 30. So that is correct. And let's go ahead and select that. This is going to be too small. This is only going to get up to 29. Okay. Consider the following class definitions. Well, actually, let's just take a quick look here. We have a class called flyer, and we have subclasses called bird and sparrow. Assuming that both flyer and bird have default constructors, which is or are valid in a client class. Let me move this in. I think we can see all the relevant stuff at once. All right. Flyer, F1 equals new bird. All right, so this kind of relationship, an inheritance relationship, is called an is-a relationship. So a bird is a flyer, and a sparrow is a flyer. So since a bird is a flyer, you can put a bird object in a flyer data type. So 1 is fine. Bird, well, hold on. Oh, bird extends fly, I'm sorry. Okay, so it's, it's going all the way down. Fly read it wrong. Flyer, bird extends flyer, and sparrow extends bird. So a bird is a flyer. A sparrow is a bird. By extension, a sparrow is also a flyer. So really all of these work. A sparrow is a bird, so this will work, and a sparrow is a flyer, so this will work. So actually all of those will work. Okay. Consider the following declarations in a client class. Sparrow S equals new sparrow. Bird B equals new bird. Which of the following method calls would be legal? S dot fly. So S is a sparrow. That'll work, yeah, because this has because bird has a fly method. It's public, so it's inherited by bird. I'm sorry, it's inherited by sparrow. So you can call the fly method on a sparrow. All right, bird, fly low. Well, fly low is a sparrow method. So it does not go up to bird. It doesn't work that way. You inherit from parent to child, not from child to parent. So B, fly low, is not going to work. S fly low, and it requires a sparrow as a parameter. But what we're getting here is a bird as a parameter. Now again, a bird is not a sparrow. It doesn't work that way. So you can't send a bird method in there where it expects a sparrow. So really the only thing that's going to work here is number 1. Okay. Which best describes what the print something method below does? All right. So this is just going to test your understanding of a substring method. What is going on there? Okay, now I can move it. If the length of the input string is greater than 0, then we will do this. Substring has two methods that you want to be aware of. One takes a starting index and an ending index, and one just takes a starting index. Now, if you use a start index and an end index, the start index is inclusive and the end index is exclusive. So when you say s.substring 0, 1, you are not going to get the characters at 0 and 1. 1 is exclusive. I usually remember this by subtracting the first index from the second index, and that'll tell me how many characters am I going to get. In this case, it's 1 minus 0. So s.substring 0, 1 is just going to give you the first character of s. Now, if you do something like this, the second one, s.substring, and you give it a single index, what you're going to get back is you are going to get the string starting at that index and going all the way to the end of the string. So this is a print. It's not a println. So it's just going to recursively print the string. So, oh gosh, maybe we could do it with like a simple example and say the first time through here, if we call print something with cat, what it's going to do is print the first character of cat, C. And then it's going to call print something again with the rest of the string, which is A and T. As it goes through the second time, it's going to print the first character, and then it's going to make another recursive call to the rest of the string, and it is going to print T. And at that point, let's see, print something, S substring. Well, actually, no. It's so it's going to go again. Hold on. Now I'm confused. C-A-T. So the T comes through there, and it prints that, and then it calls print something S substring 1. But at that point, the length is not greater than 0, so it's going to stop. So it'll just print the string, one character at a time. Refer to the following method that finds the largest value in an array. Okay, let's see what the question is. Which replacement for some value will always result in correct execution of the find max. Okay, so there's two main ways. This is a common question. There's two main ways of finding the largest value in an array. I mean, in either case, something like this, you're going to iterate through the entire array, and then return max. But what do you initialize max to? There's a couple of things that will work here. One is you initialize it to integer.min value. So that guarantees that unless the entire array consists of nothing but integer min values, that you are going to eventually hit, and probably with the first item, you're going to hit something that's greater than integer min value, and it is going to be greater than max because max is integer min value, and then the element at that index will be put into max, and then you'll just keep going. And every time you see something that is greater than the max that you've previously seen, then you will update max. Now, the other way that this will work is just put the first element of the array in max. Okay, if that's the biggest element in the array, then you go through the rest of it, you're fine. If there's some bigger value later on, then it will replace max, and you're still fine. So those are the two ways to make it work. You can iterate through the array. And by the way, if this is reversed and you're finding the min value of the array, then yes, you initialize to integer max value. I actually like this one better, where you just put the first element in. I suppose you'd have to do a check there to make sure that there is that the length of the array is greater than 0, but either one of those will work. 1 or 3. 1 or 3. All right. An opera company has a large list of donor records. Sorted alphabetically by name, each record contains the amount of money donated, sorted alphabetically by name. Okay. Donated in the current year. Which of the following represents the most efficient way to find the name of the top donor in the current year? So this is going to require you to have some understanding of the time complexity of algorithms. An insertion sort is O of n squared. It's not great. Selection sort is the same. A merge sort is better. Merge sort is O of n log n. Okay. Binary search is not going to work because it's sorted by name, and you're trying to find who gave the most money. A sequential search is O of n. So that's actually the best. You're just going to have to start at the beginning and go through, find them all. So that is E. Okay. Questions 18, 19, based on the following. Consider the following classes. We have pos int, positive integer, and then we have a class called even pos int, which is a subclass of pos int, and it returns the next consecutive even int value. All right. The question is, which of the following declarations in a client class would cause an error? Let's move it back over here. We should be able to see it. Pos int, p equals new pos int. Nope, that's as vanilla as it gets. So there's nothing wrong with that. Pause int even equals new even pause int. Well, an even pause int is a pause int, so you can put an even pause int object into a pause int variable. So that's fine. Pause int. Is there any none of the above? There isn't? Okay, well, it's going to be number 3 then. Pause int p equals new even pause int 8. What's wrong with that? There isn't anything in even pause int. There's no constructor, so it gets a default constructor. And the default constructor does not have a variable. There's no constructor in even pause int that takes a variable. So that's wrong. Oops, I didn't mean to go next. I wanted to say show answer. Okay, it's good. Which of the following is a correct implementation for the get next even method? Okay. Okay, number 1, return value plus 2. What is value? Value is up here. It's a private variable in the parent class, so it's not accessible in the child class. So we can't do that. Return get value plus 2. What is get value? Get value is a public method in the parent class. It gets inherited in the subclass, and so we are allowed to use that. Number 3, return this dot get value plus 2. Well, you don't need the this in this case, but you could do it. So what is the question? Which is a correct implementation? Well, 2 and 3 will both work. So let's go with that. Okay. All right, consider a date class whose partial representation is shown below. We've got a date, we've got a month, day, year, we've got a constructor, and there are other methods and constructors, but there is no compare to method. All right, which of the following must be true? If D1 equals D2, no. That's not how you compare objects. You don't compare objects with a double equals. B, the test if D1 equals D2. It's not going to cause a compile time error because there is an equals method in object, and date will it will have an equals method, but it won't. I don't think it'll work. I think you would have to implement your own date method. Wait a minute, which of the following must be true? The test if D1 equals D2 is true. No, because there is no implementation of that. The test if D1 compared to D2 equals 0 is true. No, because there is no compared to. It says that right here. The test if D1 compare will cause a compile time error. Yes, it will cause a compile time error because that method does not exist. All right. A square matrix is declared as int, mat, new int size, where size is an appropriate integer constant. Consider the following method. All right, before we look at it, let's see what we're dealing with here. All right, so we've got a 3 by 3 matrix, and that's going to be passed into some mat, and then a value will be returned. Okay. Yeah, I don't really recommend doing these in your head. although this, well, let's start it out, and actually let's over here, we'll have a total initially 0, and then eventually we will need a C variable as well. So the outer loop is R equals 0, R is less than mat length. So R will go from 0 to 2 in this case. Oh, I didn't scroll this the right way. These numbers on the bottom here are 7, 1, and 2, even though I don't think you can really see them. For int C equals 0, C is less than or equal to R. C plus total equals mat RC. So that is C 0, 0, and that is this number right here, 2. So this is now 2. Okay. C gets incremented to 1, and now it's too big, so we can't do the inner loop anymore. So now we're going to go back to the outer loop. Outer loop. R is now 1. C is back to 0, and we are going to add the matrix at 1, 0. Again, these are row major, so the first number is the row, the second number is the column, and so 1, 0 is 4. If we add that to the total, it is going to be 6. We are going to increment C. C is still less than or equal to R, so we add 1, 1, and it becomes 11. C goes to 2. It is now bigger than R, so we have to go back to the outer loop. This is 2. This is going to be back to 0. And it's going to add the 3 numbers in the final row. It's going to add the first number in the first row, the first 2 numbers in the second row, and 3 numbers in the third row, 7, 1, and 2, which add up to 10. And so by the time we're done adding those, we're going to have a total of 21. What are our answer choices? Fortunately, one of them is 21. I think I just hit the pause on the record instead of show answer. So scroll this up. 21 is correct. All right, let's go. 22 and 23 are based on the following. So we have a performer class. I don't want to look at that any further for now. We have a dancer class that is a subclass of performer, and we have a ballet dancer, which is a subclass of dancer. All right. The purpose of the constructor ballet dancer, which takes a string, is to assign a user-provided feature to a ballet dancer. When a ballet dancer object is constructed. I'm not sure I understand that. What is down here? Do routine. Well, all right. Which of the following replacements for implementation code correctly achieves this goal? Implementation code. So that would be, where's the implementation code? Oh, it's right there. Ballet dancer. So it's how do we write a constructor for a subclass? All right, well, there's 2 constructors here, actually. There's a ballet dancer constructor, and it calls super, which is the constructor of its parent class. That is right here. The parent class is dancer. So this gets called. If this gets called, then this gets called. But they seem to be interested here in the ballet dancer string with a string input, a specialty. To do this, I think we need to look all the way up here. Okay. So this is a separate constructor. All right, ballet dancer. It takes a string. It's still going to need to call the super. It's not going to call this number 1 here because that doesn't take a parameter. This one makes sense because it's calling the superclass constructor that also takes a string input. The third option is just to set specialty to specialty. I don't know that that's going to work. No, it's not going to work because it's private up here. It's private, so the subclasses have no access to it, and so the only thing that's going to work here is number 2. No. You got to show the answer first. All right, so that's correct. And we have the same classes. A client class has an array list, performer, performers that is initialized with many different objects that are subclasses of performer. Where are we? Each subclass has an overridden do routine method, similar to those in the dancer and ballet dancer classes. What is the effect of executing the following code segment? Okay, again, this is just polymorphism. So all of the classes can have their own do routine method. It's public in performer. So it is inherited by subclasses, but it can be overridden by subclasses, which it is in do routine for dancer, which it is in do routine for ballet dancer. And as it says, each subclass has an overridden do routine method. It's just polymorphism. So you go through there, you call do routine. It's going to call do routine on whatever kind of object is in the performer variable. This one. Let's take a quick look at the other ones. Do something special will be printed for all of them? No. That's just the top level. That's in the performer. That's wrong. Backflip and spin will be printed for everything. No, that's just for the dancer. There will be a compile time error. There can be different types in array list performer. No, that's wrong. You can have performer and you can have any subclass of performer. A runtime error will occur. No, there's no reason for a runtime error to occur. So that's it. That is just vanilla polymorphism, which you should have a good command of. Okay. Class has a two-dimensional square array. A two-dimensional, what is going on here? 1, 2, and 3. What is with, I guess I'm going to have to read this because I don't understand why there's like 9 different answers. The array is initialized to have size, rows, and columns. Consider the following method. Fill array, I equals 0. R goes from 0 to size. C goes from 0 to size. It is a square. It's square. All right. If I is less than, all right. I'm going to have to think about this a little bit. If I, yeah, I'm gonna have to pause and look at this for a minute. Um, okay, I mean, I'm gonna have to make an assumption here, and that is, well, here, we're not gonna be able to scroll this and see it at the same time, but I think that answer 1 is in fact this, okay? That's a 4 by 4 matrix. That answer 2 is in fact this, which is a 3 by 3 matrix. And answer 3 is that, which is a 2 by 2 matrix. So, does it say that the string is obtaining? It doesn't, but I guess we have to assume that. All right. So it's going to fill, this is going to fill the matrix with, oh my God. Hang on. So this routine is it's a nested loop, row, column. It's going to fill, if I is less than string.length, there's a counter here, I, and it gets incremented as we go through. Now, it looks like in each case, the string is obtaining, which has a length of 9. All right. If I, as we go through here and count, is less than the string length, then we're going to fill everything after that with zeros. So, oh, here it is, after a call to fill array obtaining. Okay. I'm going to read this a little bit more carefully. I was just completely mesmerized by the 1 through 9 answers. If size is 4, then this is fine. obtaining. Now we're out. Now I is no longer less than the string length. And so we fill everything else out with zeros. So that answer there is fine. In this one, I is, well, there's 9 places, and so the string is 9 characters long, so we'll fill it out perfectly, obtaining. In this one, we don't have room for all the letters, but it'll just fill what we have and stop. This is a 2 by 2 matrix, OBTA, and based on the assumption that I made regarding what the answers are, that the answers are really, 1 through 4 here is 1, 5 through 7 here is 2, and 8 and 9 here is actually 3, that the answers would be 1, 2, and 3, that those are all fine. Okay, good. This is a weird test. There was one other one in here that where the answer was just wrong, and I skipped it. There was one other one that I thought was wrong, and I went ahead and did it. But anyway, all right. Let's let list be an array list containing these elements: 4, 5, 6, 2, 1. Which of the following statements will cause an error? Refer to following method, insert. Precondition, array list is an array list. As integer values, they are sorted in decreasing order. And we want to insert element into its correct position in the list. Okay. Suppose that the element to be inserted has value -8, for which list will the method work as intended? Well, what is it going to do? It takes the list, and then it takes the element. The element is -8. Index is 0. While element is less than the list element at the index, increment the index. Once we've done that, then add the element to the next index. All right. Well, that should work. They're also, all 3 of them are sorted in descending order. So the first one we would go 0, 1, 2, 3. We didn't get it. It goes to 4. We do a list add with 4. But the list add with 4 should expand the list and add it. 2 is actually within the bounds of the list. 3 is not. But again, it should expand the bounds of the list and add it. So it looks like they would all work. Let's see. It says only number 2 will work. I don't think that's correct. Okay, well, let's take a look at something. Hang on. All right, let me see if I can pull this up. Okay, here's an array list add method. Try it yourself. All right, we'll try it ourselves. So in this case, we've got an array list of cars, and it adds 4 cars to the array list, and then it adds a 5th car at index 2, Toyota. So that's right here. That works as expected, but really, my understanding is you want to do an add to an array list, and you want to use an index. The index has to be greater than or equal to 0 and less than or equal to the size of the array. So if I wanted to add something at 4 here, and 4 is the size of the array, it should put Toyota at the end of the array, right? Here, let's run it. Yeah, that's not an error. So revisiting this, using 4 as an index on an array list of 4 is not an error, despite what they are telling you here. We just had a question like this. Oh yeah, it's right here. It says which one will cause an error. And we have a 5-element list, and we do an add with an index of 5. That's not an error. A get on index 5 is an error. An add on index 5 is not an error. And yeah, it's not an error on this either. Refer to the following declarations. Hang on, let me move this out of the way. Why can't I move it out of the way? Okay, refer to the following declarations. We've got an array of birds, strings. We've got an array list of strings called bird list, but currently empty. Which of the following assigns the elements of the birds array to bird list? The final ordering need not be the same as in the birds array. All right, so let's take the first one. This is the classic way to do it. It's like a for each loop. For every string B in birds, bird list dot add B. Okay, take each string out of the array and add it to the bird list. Well, I don't mean take it out of the array. Take it from the array, add it to the bird list. Perfect. So 1 is good. 2, for string B in bird list, birds. See, that's backwards. That's going from bird list to bird, and in any case, arrays don't have an add method. All right, number 3, for int I equals, all right, so they're doing this backwards. For equals birds dot length minus 1, I is greater than or equal to 0, I minus minus. So they're going to add the birds backwards, starting at blue jay, then parrot, then robin. And then we do this, bird list dot add Index. Okay, so that's why it's not going to work. Without the index, it would work. But the first instance of I here, I is going to be initialized to bird.length, which is 3, minus 1, which is 2, and then we're going to go birdlist.add at index 2. It's not going to let you add to an empty array list at index 2. So that's out of the question, and the answer is just the first one. The first one is the only one that's going to work. All right, next two questions are based on the following. Consider the following item and sale classes. Item and sale, all right? Item and sale. Without looking at those in great detail yet, let's see what the question is so we've got some context. Which of the following correctly replaces code to create a new item in the sale constructor to initialize the item list array? Well, let's see. The item list array. Where's the item list array is down there. All right, so we're in sale. So we have sale. What do we have in here? We have number of items in the sale. We have item list, which is an array of items. Okay, constructor, public, sale, int, the num items. Okay. Wait a second. Okay, so where are the items coming from? All right, sale, that's the constructor. All right, so here's the constructor. We have num items. It is the num items, and then we initialize an array, and then we have a string for the item description. We have a double for the item price. We have for int I equals 0. I is less than the num items. Oh, I see. And then we read the user input. Okay, read the user input for item description and item price. Okay, and then item list I equals the item list is an array of items. So how do we create an item? Okay, so an item requires a description and a price. Okay, so then item list I is going to be equal to, well, first of all these things that say new item list, those are out. We have get description and get price, but I mean those don't help us. We're going to read user input for item description and item price, and then we're going to do this. Item list I equals, create a new item and pass in the description and the price, which is what is required by the constructor, by the item constructor. All right. Next, which represents correct code to calculate amount in the total paid method. Where's the total paid method? Oh, it's down here. All right. Well, we're going to iterate through item list and add the prices. So let's see. For each item in item list, total plus equals item dot price. That's not going to work. Why is that not going to work? So this is a common thing to get you to put the wrong answer, and that is that price is private. So we cannot directly access price. It does say that there are accessors for get description and get price not shown, but we would have to use those. Okay. Next, for item in item list total plus equal item list get price. No, item list doesn't have a get price method. For each item in item list total plus equals the item and then call get price. Yes, that is exactly correct. Okay, and then what are we going to do down here? We're going to create a new sale object. No, I mean that's ridiculous. I hope that you would not even consider those. All right. Okay. Consider the insertion sort method below, which does not always work as intended. All right. The intention of the programmer is that the method will sort in descending order. Okay. The programmer intends that after k passes through the outer loop, elements array 0 through k will be sorted with respect to each other, but not necessarily in their final sorted position. Right, so that, I mean, that's how an insertion sort works. Each element in the unsorted part of the array will be moved to the left until its insertion point is found in the sorted part of the array and then inserted into that slot. The method doesn't work as intended in every case. Which of the following arrays will cause an error if passed as a parameter to the method above? Okay, yeah, so I mean that's how an insertion sort works. Basically, you have a one element sorted array, and then you take the second element and you move it to the left as needed until it's in the correct position. Relative to the first item, now you have a two-element sorted array. Now you go to the next item and you move it to the left as far as needed until it's in the right position. And once you've done that with all the elements, it's sorted. Okay, so let's look at what's going on here. So for int I equals 1. Actually, let me write some of these down. I would rather not have to go through the each sequence, and it might become apparent what's wrong here if we just look at the elements, so or at the algorithm. So we start out with I equaling 1, and then we go in here and we say temp equals what? Array at I. So the first time through, that is going to be array at element 1. Okay, then we have j. J equals I minus 1. So the first time through, j is 0. All right, so this looks a little bit awkward here. All right, while temp is greater than array at j, which is 0, we do not want to go into this loop. And the reason that we don't want to go into this loop is this right here. I mean, j is already 0. So if we go into that loop, j is going to go to -1. So if there's a sequence in which temp or array at 1 is greater than array at 0, array at index 1 greater than array at index 0. Hopefully there's only one of those. Let's take a look at the answers here. Array 1 greater than 0. No, 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 yes, and no. All right, so this is going to be a problem because that is going to send the j index to -1. Okay. All right. The elements of array ARR are to be sorted In increasing order, what represents the first step of a merge sort? Find the smallest element. No. Compare the first two elements. No. Compare. No. Compare. No. The first thing in a merge sort is to split the array in half. So you'll need to have some familiarity with a merge sort algorithm. It's recursive. You know, you break the array in halves, break the halves in half. Eventually, you'll get it down small enough where you can. Well, you may have one element. You may have. Eventually you'll break it down to like a single element and then just merge them back together. But the first thing is you've got to break the array in half. That is this answer right here. Okay. All right, so let's try and trace it out here. So this is called a mystery 7-3. All right, so we have M7 and 3. We'll drop in here and say, does n equal k? No, it doesn't. Is n greater than k? No. Else return a mystery k minus n, which is 4, and n, which is 3. So now we're calling mystery 4, 3. Eventually, we want to hit a base case here where n equals k, and then it'll just return the answer all the way up. All right, so we call mystery 4, 3. Does n equal k? No. Is n greater than k? No. All right, so then we have to make a call to k minus n, which is 3, and 3. Wait. Is n greater than k? Okay, I'm sorry. K minus n. No. K minus n. 4 minus 3 is 1. So we'll call mystery 1, 3. Right? All right, does n equal k? No. Is n greater than k? Yes. So we will return mystery at k plus n, which is 4, and n minus k, which is 2. Right? Call it again. Does n equal k? No. Is n greater than k? No. So we will return mystery k minus n. Oh, I think we're getting close. Mystery k minus n, which is 2, and n is 2. All right, so if we call that again, n equals k, yes. So it returns n, which is 2. It just returns it all the way back up. So the answer to that is 2. I don't know a faster way to do this or a better way to do this. I mean, you know, there's enough recursive calls in there that if you can do it in your head, I mean, I don't know. You're way ahead of me, so you're gonna have to just trace it out like that. You know, if you're a person like myself of, you know, moderate intelligence. All right. All right, the next two will look a little different because I had a problem with the recording. They are already done. We'll revisit them. Consider the following program description. A programmer plans to write a program that simulates a small card game. No more than 4 players. Each player will have a hand of 10 cards in which each card has a suit and a value. This game will involve either adding cards to a hand, or discarding cards. First player to have 0 cards left is the winner. In the simulation, as the game is in progress, each player's hand is displayed on the screen. The programmer plans to have a short class whose main method has just 2 statements. Game, G equals new game, and G dot play cards. The game class will have several objects. A display, a deck, a card, and a player group. The player group will have a list of players, and each player will have a hand of cards. All right, so that's a long lead in to a short question, which is the relationship between the player and hand classes is an example of. Okay, well, it gives us the answer right here. Each player will have a hand of cards. All right. Well, just as inheritance is a relationship, composition has a relationship. So if each player has a hand of cards, that is composition, meaning you'll have a player class. One of the properties of that class will be a hand class. So a player has a hand, and that is called composition. All right. The next one, which I selected the wrong answer, and I'll tell you why. What is a reasonable data structure? All right, well, maybe reasonable people can differ on this. What is a reasonable data structure for a hand object? Each hand starts with 10 cards, and the number of cards can only go down. That's actually not even right. Is it? As I recall from reading this, it says over here the game where either players can either add cards to a hand or they can discard cards from a hand. So the idea that you can only the number of cards can only go down, and that isn't right. There should be a mechanism for removing a card, displaying a card, and detecting a winning hand. Okay, so let's go with the first one. My answer was 3 only. Let's start with that. An array list is a perfect data structure for this. An array list will contain 10 cards. You can add a card to an array list with a method call. You can remove a card from an array list with a method call. You can get the size of, well, it says it right here, hand.size. You can get the size of an array list with a single method call. So it's very good. Here's another one. Boolean. You have 52 Boolean values. 10 of them are initially true. The true values represent the cards initially in the hand. Okay, it's not so good because you'll have an index from 0 to 51, but how does that correspond to the cards? All I have here is 52 values that are either true or false. I mean, so where is the Queen of Spades, for example? What index does that represent? So that's a particularly bad idea. Now, the idea up here is do it as an array. I mean, you could make that work, I guess, but an array is a static data structure, and if it starts out with 10 cards and you want to take a card out of it, I don't know. How do you do that, really? Do you just replace it with, I don't know, replace it with null? You would have to decrement the number of cards. What if you wanted to add a hand? It does say that the number of cards, add a card, it does say the number of cards can only go down, but then over here it says the number of cards can go up. So An array is a static data structure. If a hand is going to contain 10 cards and it's always going to contain 10 cards, then there's nothing wrong with an array. But it's not really a reasonable, an array is not a dynamic data structure. That's all. If you see this question on the AP exam, I guess say 1 and 3, but to me, an array is not a a reasonable data structure for that. So okay, I'll take the L on that one. Next, okay, consider the card and deck classes below. All right, so before we consider them too much, let's take a look at the question for context. The programmer tests the constructor of the deck class. When the code is run, a null pointer exception is thrown. When the code is run, a null pointer exception is thrown. What could be the cause of the error? Well, let's take a look. I mean, the deck tester class object was not created with new. No. If the deck tester class was not created with new, then you're not going to be able to run it. That's going to be a compile time error. In the get cards method, an attempt was made to add a card to an array list that wasn't created with new. Let's take a look at that. Get cards, the get cards method. Okay, public deck get cards. Get cards implementation not shown. Implementation not shown. In the get cards method, an attempt was made to add a card to an array list that had not been created with new. That makes sense. There's a property here called deck. It's an array list of cards. In the constructor, we call get cards, but we haven't created the deck yet. So yeah, that's a problem. That's a problem. All right, so two is going to be part of the answer. All right, well, okay, so now we got to look at 3. In get cards, an attempt was made to construct a card object without new. In get cards, an attempt was made to create a card object without new. I got to think about that for a second. Okay, you know what? Actually, I want to, I want to revise my answer to the deck tester. Public static void. This is the main method here, so this doesn't have to be instantiated at all. So that doesn't have to be. The deck tester class object doesn't have to be created in the get cards method. Well, the implementation of get cards is not shown. So there are no methods shown here in which a method is called with a null card object, and an attempt to construct a card object without new is not going to be allowed. That is a compile error. So the only thing is this here. We have deck. We have a constructor for dec, which does not actually create the dec. It's declared, but it's not instantiated. So the only thing wrong here is number 2. Okay. 36 and 37 are based on the following. Consider the name class. All right, without going into great detail yet, let's just say that a full name consists of a first name, a single blank, a middle initial, a period, another blank, and a last name. And several examples are given here. What is the correct code for code to get first name? Where is code to get? Oh, right there. It could be more than one. To get first name. This is puzzling. Oh, I see. It's another one of these. Okay. So this is really 3. 3 is really these 3 lines here. I would say ignore the 4 and the 5. First name is no, you can't do subtraction on strings. So 1 is gone. First name equals well, let's see what's happening here. Full name. So we pass in the full name. Then we have an index. And we have full name, index of blank. Okay? So we have the index of the first blank, which would be the blank after the first name. So then we can say first name equals full name dot substring 0 index. Now if you use substring this way, the second index is exclusive. So the fact that we have the index of the blank after the first name, it would not be included in this call. So 2 is fine. Okay. Number 3. We have a for loop. For int I equals 0, I is less than index. So that is going to include all of the letters in first name. S. What is S? Oh, S is a string. It's declared here. It's initially empty. S plus equals full name dot substring I plus 1. So that is going to get 1 character at the index I. And it's going to do that for every letter in the first name. It's going to add the letters in the first name one at a time to S, and then it's going to set first name to S. So that will also work. 2 and 3 will work. So let's go with that. Okay. Whoops. Whoa. Did I just pass that? Okay. No. We're in the right place. Okay, next. What is the correct code for code to get last name? All right, get last name. Index. So reminder on index. Index, we set index to the index of the blank after the first name. So let's do this. What is index plus 4? So if we're at the blank following a first name and we add 4, or John Q. Smith, for example, we're going to get 1 is the Q, then the period, then the space, then the S. So we add 4, and we are now at the S on Smith. And if we get the substring from there to the end of the string, then it's the last name. So that's fine. That works. What about this one? Full name, substring, starting index is the the same, index plus 4, and the end index is full name dot length, which is the length of the whole string. If we use it, if we think of it as an index, it would be the index, just past the end of the string. So that would also work. If we did this, first name length plus 4. Well, first name length, if we thought of it as an index, so we look at these names like John, for example. The length is 4. The index of the n is 3, and the index of the space is 4. Camilla, that is a length of 7. But index 7 is the space right after Camilla. So really the first name length is the same as what we have set the index to. It's the index of the space right after the first name. So any of these will work, 1, 2, or 3. Okay. Consider an array. Wow. Sometimes the text is really big and sometimes it's really small. Consider an array of integers, ARR, initially sorted. Why is it there twice? I hope that's explained. Consider the following algorithm which changes the array. You may assume the existence of a swap method that interchanges two elements in the array. Okay. For I equals array length minus 1, which would be the last element in the array. I is greater than 0, I minus 1. So we're going to go through the array backwards. So int index will be math random times I plus 1. Again, I is initially going to be, okay, wait. No, there's 52 elements in there. From 0 to 51 is 52. So the length is 52. And then I would start out at 51, 51 plus 1. Take a math random and chop it to an int. That would be 52, almost 52 chop. Okay, so we'll get a random number from 0 to 51. That's indexed. And we will swap the current element with some random number. And we'll do that, let's see, from 52, 51, from 51, well, almost to 0. About 50 swaps of numbers to just random indexes. Okay. What is the best description of what the algorithm does? Reverses, no. Creates a random permutation. That's what it seems to do, yeah. Swaps each integer, no. Okay. For each I from 51 down to 0, selects a random integer, stores the result in index, and swaps array index with array I. That's pretty close to being right, except for this part here. Selects a random integer for each I, selects a random integer from 0 through 51. But the random integer is based on what I is. And as we go through this loop, I get smaller and smaller. And so the range of the random number gets smaller and smaller. So it's not a random integer from 0 through 51 every time. It is the first time, but then it gets smaller and smaller. So that is not right. Without reading all of this, since this says the same thing, that is also not right. So let's go with creating a random permutation. The selection sort algorithm sorts an array of integers in ascending order as follows. Loop from j equals 0 to j equals array length minus 2 inclusive. In each pass, swap array at j with the largest element in array j plus 1 through the end of the array. So, yeah, each pass through, we get a longer array or subarray at the beginning of the array in which all the elements are sorted. Relative to each other, they may not be in their final sorted position. All right. A student writes the following code. Let's skip that until we see what the question is. It doesn't work. What should we do to fix it? Change line 3 to j equals 0, j is less than array length. No, because we're given number 1 here that we want to loop from 0 to array length minus 2 inclusive. So when we say j is less than array length minus 1, that would be array length minus 2. So A is not right. Line 6, for k equals j plus 1, k is greater than or equal to array.length. Okay, so that is not going to work because we can't use array.length as an array index. It's too big. Change line 5 to be int min index j. Min index equals j. Okay, yeah, this is a problem. So we want to start each pass of the inner loop with the first element that is not sorted. So if we assume the first time through j equals 0, nothing is sorted. So we'll look at element 1 and then to the end of the array and see if anything is smaller than j, and if it is, we'll swap it to the front. Next time through, let's see, if array k is less than array at min index, yes. The problem is we don't want min index to be 0 every time through this inner loop. We want it to be at the first unsorted element, which is j. First time through j is 0, then it's 1, then it's 2. The unsorted portion of the array, or the start of the unsorted portion, keeps moving to the right. So we don't want min index to be 0 every time. It needs to be j, change line 10 to min index equals j. That really doesn't even make sense. J was not part of the comparison here, so there's no reason to set that to j. And then array k is greater than min index. That would sort it in the reverse order, which is not what we want. So let's go with C. Consider a program that has a two-dimensional array of int values. The program has several methods that change the matrix in some way. Here is one of those methods. Suppose that matrix M is originally this. Which of the following will result from a call to change matrix, and then we pass that in. All right, so let's look at this. We have the width, which is the length of the first row. We have num rows, which is the length of the matrix. In this case, both of those are 4. So we are going to iterate over all of the rows. We are going to iterate over, let's see, width is 4 divided by 2, and we're going to column has to be less than 2. So we're only going to iterate over the first 2 columns. Every row, first 2 columns. So nothing in the third or fourth column is going to change at all. So before we look at what this last line is doing, let's see how many of the answers have these 2 columns exactly the same. So it's 5, 7, 6, 8, 7, 6, 5, 7, 6, 8, 7, 6, 2, 3. D has that. Okay, so that's all we need to know. Those last 2 columns are not going to change. And D is the only answer in which that is the case. So we'll go with D. Right. Okay, now I can see why there's so many questions in the multiple choice, and that is because they put the, the free response questions in with the multiple choice section. All right, we'll do the free response questions in a separate video. So that is it for the multiple choice questions, and we'll see you next time.